Hello, everyone. Welcome to SIG Node meeting on January 14th, 2025. We have a pretty packed agenda. Starting us off, we have Dims. Dims here, I haven't seen him.
Yeah, I'm not sure if James is here.
Yeah, sorry, I was late on this one. Dim's asked me to stand in for him. Yeah, he wanted to just make sure that we have a plan for a lot of the permanent alpha, beta, and the ones that have yet to be promoted to GA as like a whole. I told him that we have kind of been slowly trying to migrate some of these too, but we haven't really had a discussion on all of them at once. And so that was at least what he wanted to bring that up, to kind of start thinking about like what caps we want to continue supporting and which ones we want to pull out, or whether or not like permanent, like for planning. Yeah, that's at least I think why he wanted to bring it up. And then maybe at least like we can sort of start thinking about that more formally.
I think we've been like graduating caps to GA every release. So I think we'll again review this list and make sure we aren't missing anything. Sergey, not sure if you want to add more.
Yeah, we've been tracking it for every release. We have some pain points. Not all resource managers are GA yet. And bigger pain point for me is graceful termination, graceful shutdown for a node. It was beta for a very long time. It's used everywhere, but still we don't have energy to graduate it. And recently we found issues that may be considered as GA blocking. So now it's even harder to graduate. And we're still looking for somebody to help us with that.
Yeah, I think that's one. And the evented plague one is another one we want to call out. Like we don't want to pull it out. We know it's an alpha. There are efforts going on to see how it can be pushed forward.
Yeah, and I guess I don't think he attends these calls, so some notes on those or like decisions made on these, because I think he was looking at the agenda and not really seeing us talking much about evented plague. I know we all have in this call, but I don't think we've had anything formal about what our plans are for that one.
I would say we do progress slowly on that. So I don't think we need to do anything extra this release. Maybe just review it again and see if something really painful there. Yeah, those all good examples. And like I think this release, I saw an agenda we probably will address swap. So that's why I didn't even mention it. Swap is another example of something long running, and we want to understand what the future will be.
Yeah, even memory QoS, we have an update from Peter. We'll get to that.
I do think that there are a number of these that are like effectively that they have been perma beta for a while. So I think it is worth sort of going through the list and seeing like maybe sorting based on like the latest last update and then evaluating. But I think that would probably be better done offline. Maybe I can take an action item to poke through this list.
We can keep a list of these problematic ones which are going on for a while, and then just have an update that we talked about it and we intend to keep working on them. So someone looking from the outside knows like, oh, okay, why is evented plague still alpha and not removed or not moving forward?
This is a good call out. Thank you, Kevin, for bringing it. And Dims, if you watch this, for bringing it up as well.
Yeah, this is Dims. He just asked me to stand in for him.
Great. Was there anything else on this one? Cool. Tim.
Hi. So I didn't have a chance to write up any details for this topic beyond what's in the agenda. But there's been some side conversations happening around in-place pod resize and the resize policy. So just a quick bit of background for folks that don't follow it super closely. on the pod spec, there's a new resize policy field that's per resource. And basically the resize policy just is sort of a resize restart policy. So you can say, if I'm resizing CPU, I must restart the container. So it's basically not doing in place. Well, it's in place in that the pod's not recreated, but the container does restart. Or you can say restart not required. A common use case for this is Java applications. I think the Java runtime or the JVM can't resize the memory limits when the C group limit changes, so you have to restart the application when resizing memory limits. But in most cases, what you want is to not restart. The problem is there was a decision made early on to say you can require no restart, or you can say restart is not required, but that's different from saying must not restart. So there's no way to say I want to prioritize no disruption over resizing. Like maybe I want to resize, but if you can't resize without restarting, don't do the resize. In most cases, so in your basic like CRI implementation on top of run C running on Linux, this basically the resize not or restart not required means it doesn't do a restart. There's some corner cases about kills when decreasing memory that we talked about last week, but basically it's saying it's not going to restart. And the resize policy today is handled entirely in the kubelet. So if you say restart is required, then it's going to issue the CRI calls to stop the container and restart the container. If you say restart is not required, then it's going to do an update container resources CRI call. So I would rather not plumb resize restart policy down into the CRI layer, which means if we wanted to have a guarantee that the runtime isn't going to try and restart the container, that would mean changing the contract on update container resources request. I think I looked at the container D implementation. I don't know exactly how this is done in Cryo, but I think it's basically just plumbed down into the run C call, where that's just issuing an update resources command. So it's kind of at the run C layer that this really takes effect. And I think this probably is most impactful for VM-based runtimes that can't do the in-place restart. So I guess I wanted to bring it to this group. I'm particularly interested in folks who work on Cryo and Containerd, what your opinions are. Does this seem like a viable thing to specify that update container resources, the CRI call, should not intentionally restart the container? And then if we make that change at the CRI level, we could consider, it would basically just be a kind of a documentation change, or maybe change the wording on that restart policy to say, restart not required, or like don't restart is kind of the value on that resize policy.
Yeah, I think, following up from our conversation last week, the one risk is that, there's the case in V2 where an kill would happen. So I don't know if we could at this point make the promise that a restart won't happen, but I don't think at least in Cryo's implementation, there's no part of the update container resources that restarts Cryo specifically. I don't know if run C, if there's any cases that it does. But I don't think so. I'm pretty sure the point of update is just to update in place. So I think adding that language to the CRI is fine, as long as as we know, a potential consequence of it is the container could just get killed.
Yeah, traditionally that, oh, I'm sorry, Sam, go ahead, Sammy.
I was going to say, I don't think the runtime spec actually specifies the update command. So I think, Peter, you're probably right about what runc does today, but I don't think that's standardized. I'm wondering if we might want to get that into the runtime spec, that update should be non-disruptive.
Yeah, we can get some language into the runtime spec around this.
Yeah, my memory of this is we just pipe back any error in the kernel all the way back up. But we don't restart a container if we can't increase memory or decrease memory because it's already been used.
Yes, I think part of the our delicate towing around the potential restart also came a little bit from V1, where you couldn't resize, couldn't increase the memory limit above the amount. So I think that like before we were towing the line of like, oh, we may need to restart from the qubits perspective because to actually enact that. But I agree, Tim, that the case of like, you know, saying the qubit will prefer non-disruption over restart or over resizing. I think that that's a like valid case, and I think the semantics are clear on that.
I guess in my hand. So yeah, I agree, Peter, that it's not only semantic is desired. It's actually I mean it was a conversation with VPA, and they basically saying that this feature is not super useful if there is no guarantee that we can provide on non-restarting, because VPA wants to. I mean, they have very limited way to detect that change will be non-disruptive, and they cannot mass apply some VPA policies to make cluster better in general if they don't have these guarantees. I think another question will be, do we want to have opposite policy? And I think the answer right now is no. Opposite policy saying like, please update the resize even if you cannot, if you have to restart. So today, if we change the semantics, then resize will fail if it cannot be applied without disruption. And we wouldn't have an option to resize even if disruption will be needed. So we're eliminating this option right now. And I think one of the piece of feedback from everybody should be, do we really need that extra scenario, or we can just keep it simple as it's either disruptive or it's non-disruptive?
Sorry, I'm late on this one, but I just heard Sergey's comment. I agree with you, Sergey, but I just want to point out a lot of policy. I also talked to this with the team, Claire, offline. We build it is the mechanism to make it is a seamless that can integrate with the VPA itself. So a lot of policy will be defined at the cluster level, which it is the VPA level, right? So we don't have all the data. And at the node time, we need to be careful, like to say, oh, what is API we defined? And how we are going to make sure VPA based on the historic data, all those runtime, the history, and also current global view they have, and make the best decision. So we can, the guarantee actually is provided, right? So we have like the hooks and the interface to allow that one, but that SLO and all the certain guarantee supposed should be at the VPA level, not our level. I just want to say, I don't expect the customer will using this feature manually, and maybe one or two cases before the VPA integrate. So this is why we need to be more careful about at the end level, like noise level, and what it is API we exposure to the our client, which is the VPA. I just want to say that I hope we are not over-engineer here, because make this is guarantee. There's no way for us to get guarantee. Like kernel, even account, today's kernel, SIG V2 didn't account of the memory usage is not accurate yet. So this is ongoing about the effort. Even I talked to the kernel folks last couple months and how to make that is. So then a lot of the mechanism at the user space is not 100% guarantee. We only can respect the running application, their desire, right? So disrupted or not disrupted, all those kind of things. That's all we can do, I think.
Tim, do you
Tim
want
has
to? Yeah. Did Tim hang up?
Sorry, I was talking on mute. I wanted to respond to Sergey's question about whether we need to keep the current semantics as an option. I think in the case of a runtime that's not able to do an in-place resize, where it's going to be a consistent issue, I'd much rather say that needs to be an explicit decision in the pod spec. So for instance, you're running like a Kata containers runtime class. You know that it can't do in-place resizes. You could put a validating admission policy or some sort of like API level policy to make it explicit that any resizes are going to restart this container, rather than kind of something that's accidentally trying to do an in-place resize, and you don't know, it's not as obvious whether it's going to restart or not. If there's things like the situation we talked about, if there's places where the resize is not, whether it's going to restart is not predictable, then I think that's a more difficult case that we'll probably have to deal with on a case-by-case basis.
Sure. I mean, I have the same opinion. Like, we can solve this later, and what you suggested may be one of the options. It kind of shifts in the responsibilities a little bit, but at the same time, it is an option. Yeah. Okay.
Tim or Don or people who have talked to ZPA folks, is the requested semantic that we promise not to restart a container, or we'll do our best to not restart the container? Like, what is the contract that we want to commit to?
I mean, I don't think it's realistic to say we promise not to restart. I think that would certainly be desirable if we could provide that guarantee. But I think having some guidelines, at least kind of making sure we have a good understanding of the cases where it might trigger a restart. And then I think this is what Don was talking about in terms of like cluster level policy. If we know that, let's say, downsizing memory limits carries a risk of restart, then rather than trying to put all of the protections at the kubelet layer or the node layer, like we could add some policy to VPA to make downsizing memory limits much more conservative. So, leave a large buffer, make sure there's a lot of historical data to make that a safer operation that way.
Can I chime in? Because since I just respond to this one. So actually, I hope people, everyone think about the step back a little bit, look at the big picture, right? So actually, to make this feature is really useful, you also need to figure out who do this initial configuration, the size about the container, right? So the size of container could be, and the user measure and think about the peak usage. And then will be way bigger, right? Could be like the system try to say, oh, by average, and what it is the average usage, and ignore of the peak usage. So depending on who decided that one, or depending on how the policy, even like automated init of the configuration of the container, right? So you base on like I try to start with average, which is smaller. Then when there's the peak usage will coming, I predict that one. Then we enlarge about the container, right side of container with the large. Or I just okay start from the peak, but I by average and based on the historic data, I adjust and shrink, right? So the first cases I mentioned here, depending on the policy how to use it, actually we don't run into like because we want to resize with smaller and force this is restart, right? So, but if we go with the second one, then you end up have a lot of because we right size in wrong and then run into the womb cases, right? For the SIG womb cases, because we couldn't reclaim after enough faster enough. So there's the many things. So that's why I try to make sure in here, more is at the API level. Like the team is also focused on the API level. That's what the team and I discussed for last several months. Instead, that we give them mechanism because we don't know even like the different kernel and how reliable and also different workload, different type of workload, right? Their disruption tolerate rate also is different. So that's kind of things we need to have the global knowledge, global view, and also production environment. So that's why we are more focused on the mechanism to make that more efficient and to apply those policies at the global level. Yeah.
Okay, and I wanted to just chime in on Peter's question on what kind of policy we need to have and like what kind of expectations we have from kubelet. I think one of the thing for me is for container runtime, a container runtime needs to respect it as much as possible. And like, for instance, if there are some NRI plugins and this NRI plugins cannot apply whatever they want to apply without interfering with the workload or like restarting it in any sense, then it needs to choose not to do that and return error rather than interfere with the workload and make it like make interruption for the workload. So that is kind of a policy I suggest we apply for this update operation.
But that would work as normal error operation from like runC. So you like if NRI plugin will generate error, it will be returned as error coming from runC.
I don't have an answer for that because NRIs can do crazy things, right? So we don't know what NRI means.
Maybe what I mean, like if you get the update message to the NRI plugin and it cannot do something, it will just return error.
Sure, perhaps. I'm just saying that it needs to return error rather than try to do something disruptive. That should be a contract. I mean, today contract allowing you to say like NRI plugin can do disruptive thing as long as it applies the resize.
I don't know if we can ever really properly define that contract because ultimately the NRI plugin has access to the container lifecycle and it can just say, you know, it's time to stop this container or something, you know. So the we can ask really nicely and hope that anyone who, and also like maybe audit NRI plugins that people add, but like at the end of the day, like giving access to the container lifecycle and specifically allowing an NRI plugin to trigger a container stop means we don't really have any control and there's no really guarantee we can make.
Well, in overall, the system should be independent, right? So nobody prevents you to say like CRI CTL and directly say stop that container from outside of Kubernetes stack.
Or if you're on the node, just killing the container process.
Yeah, that's what I meant, yes.
John?
Yeah, I just want to say we may not be able to guarantee it because of NRI, but I think that the point is that a user wants their workload to work properly. And if NRI plugins don't get installed without, you know, some administrator or somebody doing something. So if they've introduced instability into their system, that's their problem. From a Kubernetes perspective, we should say, this is the expectation that, you know, Kubernetes and the container runtime won't do this. If NRI plugin decides to do it, that's the user's problem. But like, let's just state it clearly what our expectations are.
Yeah, I agree. Cool. So I don't know how we're feeling on this topic. It seems we have a couple of, it seems we have like consensus on like this is something that, you know, we should do generally. So I think that's good. Was there anything else people wanted to mention on this topic? Cool. Alrighty. Thank you, Tim. So yeah, I have a corollary sort of. Last week we talked about the C group v1, v2 difference in pod update or container, you know, C group updates and memory. And I talked with my friendly neighborhood kernel engineer, and basically his feeling is that is kind of like, and we kind of talked about this a little bit, but like that's kind of the idea of memory.high, is to set the threshold under which the kernel will try its hardest to reclaim, or between memory.high and memory.max, the kernel will try its hardest to reclaim memory before killing. But he did say that the soft lock issue that we were hitting with memory QoS was like, you know, he did admit that was like kind of a weird situation and not really desirable. Currently, the kernel has a fixed sort of ratio of like amount of time it tries to spend reclaiming memory and the amount of time that it will just be like, okay, I'm going to kill the container or the process. And since that's fixed, like we get this deterministic behavior of like doing the constant like soft lock situation. So he is going to investigate adding a knob to sort of tune that, so that in some cases we could ask the kernel to be more aggressive with killing instead of attempting memory reclaim when it's in that sort of range. A consequence of which would actually mean we're making the situation a little bit worse for VPA, because if we set the memory.high to an amount and the container is aggressively asking for memory between memory.high and memory.max, then it's more likely to get killed. But the consequence of that is that we can trust that memory container who is constantly above memory.high eventually will get punished by getting killed. So we can sort of better trust setting that and like not have that section of memory be locked in the kernel. So that is an idea that we talked about, and I wanted to just mention. Tim?
Yeah, thanks for following up on that. I think even if we had this in place and we're using memory.high, we'd probably still want to do that usage check in the kubelet. So this would only really be hit if between the kubelet checking the memory usage and actually making the resize call, it had gone over that limit. So probably we're looking at a pretty small window, so there probably wouldn't be a ton of memory that needs to be reclaimed in that case. Yeah, I wonder if if that helps us make any more guarantees around what the behavior would be like, or if, you know, there's still a risk that if the process is like really aggressively trying to allocate memory, it would hit that.
Yeah, I think that the theoretical promise that memory.high in this case could give us, which is going to be a little bit changed by the work that Wyman is going to do, is like if we set the memory.high value lower, like, so if we first set memory.high to be low, like whatever the lower memory limit is, and then let the kernel like sort of do the reclaiming, then there could be we could better guarantee that we can then move the memory.max value down because we know that the memory's done that reclaiming. The risk now with this change being that, okay, now it actually will sometimes kill in that situation. Or like after that, like between when we have updated memory.high and when we're updating memory.max. So like, I don't know if it doesn't help us make a guarantee, but it does help close the gap of the talk tau race if we do successfully drop the memory.high. And also the kernel is, you know, as long as the workload isn't being super aggressive, but it doesn't help us make a guarantee. We promise to never kill this container.
Yeah. But even with C groups v1, like if you're really aggressively allocating memory and you successfully lower that limit, like you still might get killed after lowering the limit, right?
Right, but the risk being the difference being like in the process of the update we wouldn't accidentally trigger an so it's like it's a little slightly different. That is true though. That is a good point.
And what layer would you picture doing that setting memory.high followed up by setting the memory.max?
Yeah, I would think that would end up being probably in the OCI runtime. We'd have to sort of talk through the exact semantics of it, but I think that's too high level for anything else. It could be part of the update container resources process of like, okay, we have we know the memory limit is lower than the usage or something, or the memory limit is lower than the max. So let's set memory.high, allow the kernel to do some reclaiming, and then set memory.max. I think could be the workflow, but it's not totally clear to me yet.
Okay, thanks.
Not sure who was next.
I think myself. Yeah. So when we're saying that, I have two questions actually. So Tim, when you say we will check memory before trying to apply the limit, do you know if we can safely check what is reclaimable and what is not reclaimable? So in other words, like, does memory.high approach will reclaim something that we cannot account for and like don't know about, like that it's reclaimable?
So basically the kernel, from my understanding, I don't have a perfect understanding of it, but my understanding is that the kernel will, once memory.high is reached, it'll be reclaiming everything above, like it'll try as hard as it can to reclaim above memory.high. And if it cannot reclaim anything else, eventually it will kill, I think is the proposed changed behavior. So if there is an amount of memory that cannot be reclaimed and the memory is still above memory.high, I think the desired behavior would end up being kill.
Yeah, I guess my question is a little bit different. So if we go with Tim's current approach with Kubel checks the current usage and only applies the new limit if usage is lower than the limit, will we be able to check that this limit that we try to apply is actually lower, can be reached if some cache is reclaimed? That's basically
That's a good question. I don't know if the kernel specifically, like in memory.stat, for instance, says which of the memory is specifically reclaimable. I don't know.
Yeah, my worry is that we can get into situations that we never can. Kubel never thinks that usage is lower just because there are some cache that is always a little bit higher than we wanted to be, and it's basically like never below this usage.
Yeah, that would be an interesting question to figure out.
So maybe that's another reason to get kernel opinion on like how can we apply memory.high for a little bit so it reclaims as much as possible and then like backs off. Like that will be a really cool feature to have. Apply memory high for 100 milliseconds, like something like that. And then another question, like, so this contact of yours, he said that no way they will replicate C group V1 behavior. So kill is forever there in C group V2, or we can continue.
I don't know. Like, we kind of got that. That's a good question. I think we got distracted by just talking about the limitations of memory.high, so I didn't actually get a concrete yes or no answer on reverting back to the V1 behavior. So I will follow up on that.
Yeah, I think that's we should probably press on that a bit and see if we can get that, like make a case for why that may be desirable.
Yeah, good idea. I'll follow up.
I also have a couple of questions.
Yes.
So, are we like, is your point of contact planning to change the behavior in the kernel? Like the problem last time was the workload that I was testing it with was very aggressive, and then there was a live lock scenario. So, is there going to be a change around that?
The plan is to add a C group like field that we can adjust how aggressive the kernel will reclaim versus kill in that case. So it won't change the default behavior, but it will potentially allow us to tune like the ratio of reclaim and kill so that we don't like, so in the case it's really aggressive, it does get punished by getting killed.
Okay, and that's a proposed change in kernel, or is it already there?
It is an idea at this point. I don't think that it's been submitted anywhere, but I can CC people. He usually adds me to the kernel list when he proposes it, so I can CC people if you want to be added to that.
Yes, please. I would love to follow that. And are we looking at memory.high specifically for Tim's update, like supporting Tim's update case, or is it also for memory? And the follow-up question is, if we just want to trigger reviews, there might be other ways, like memory.reclaim, like setting memory.reclaim, or maybe something else that we don't know.
Yeah, so I asked based on, I started the conversation based on our conversation last week about VPA, and it sort of became a conversation about the limitations of memory.high. I think really the way that memory.high will be helpful for us is memory QoS. I think like the proposed changes will actually make it worse for VPA a little bit, memory.high specifically. And I forgot what the follow-up piece to that was.
The other one was, if we want to trigger reclaims, there might be other ways that we should explore generally. That's it.
Yeah, that's a good point. Yeah,
yes,
so maybe we do a little more investigation on the update container piece, seeing which C group fields we can play around with and potentially help VPA case with.
Okay, sounds good. Yeah, I mean, I'm all up for if you're able to support the memory throttling anyway, because it has been blocked for a while.
Yeah.
Thank you.
Totally. Yeah. Were there any other questions on that? Really supposed to be a quick update. Cool. I'll keep folks posted on how that conversation goes, and I will follow up on the V1 behavior change. Okay, we have Itamar talking about node swap. Oh, you probably want to be a host.
Yeah, hi.
Yes. 1 second. All right, you should be able to share.
Okay, can you see it? Okay, great.
Yeah.
So yeah, I wanted to talk about the path to Jiang node swap. Basically, there were two main concerns, as far as I can tell, regarding node swap. So I'm going to quickly talk about both of them and how I think to address them. So first of all, the first concern was about evictions. So previously, basically, the eviction manager is not aware of swap in any way, and this was concerning. So there's a PR ready for review, contains E2E tests, and I'm going to quickly explain the idea behind it. So basically, this is a replacement PR for Kevin's PR, and I think that with Kevin's implementation, there are basically two problems. First of all, swap needs to be configured separately, which is a very hard thing to do, which is nearly impossible for most applications. The other thing is that it decouples swap and memory entirely. And I think this is a mistake because swap and memory are intertwined, they are inherently connected, and they should be coupled and dealt with together. So basically, the approach that I'm taking is, so first of all, I'm defining the accessible swap is the amount of swap that pods can use, basically. Because according to the limited swap, every pod gets a swap limit. So accessible swap is basically the sum of all limits of all pods. So basically, the main idea is to treat the accessible swap and swap just like capacity and regular memory. So first of all, the accessible swap will be added to the machine's capacity when the eviction manager would try to think if a certain threshold is met or not. Additionally, swap memory will be considered as regular memory when checking if requests are exceeded, or comparing between pods about memory consumption. Another small addition is that whenever there's memory pressure, then the eviction manager will rank pods that exceed their limits with swap and memory usage to be evicted first. So currently, I mean, without swap, basically crossing limits leads you almost always to an immediate kill. So we allow crossing limits, but if there's an eviction, they would be evicted first. And I do want to mention that we've been testing this approach internally within Reddit for some time now. It's proven to be pretty stable. Yeah, and I just wanted to hear your thoughts about that.
How will this work for, like, do we differentiate between, like, when we get to a state where there are guaranteed pods and burstable pods are tracked separately for swap? In that case, like, we wouldn't want to kill guaranteed even if they are swapping, right? In case of JVMs, if they need swap, they're using swap and they're guaranteed.
Guaranteed.
Guaranteed pods can't use swap whatsoever. The only QoS class that can use swap is burstable.
Oh, you mean currently, right? But I'm talking about, like, as we evolve this, we'll also want to solve cases where guaranteed is given access to swap, and then we'll have to differentiate even within users of swap, which one should be killed first.
Yeah, right, and that's a good point. Actually, Paco was starting a discussion in the PR about something similar that I think is related. But I mean, what I think is that in order to GA swap, we need to come up with a strategy only for limited swap, because this is currently the only swap behavior. I do think that we need to think of how it would be evolved in the future. In the PR, basically, I listed a couple of alternatives. Either we tie this eviction strategy to the limited swap behavior, or we can come up with another field maybe for a strategy, or we can think of doing something more drastic within the eviction manager, maybe a plugin mechanism or something like that. But yeah, that's we can continue this discussion on the PR, I think.
From high level, I like the approach the direction we are moving forward. But I agree with Manu. Maybe I didn't heard Manu clearly. It's more like is if the guarantee don't using of the swap, right? So then the eviction manager, based on the last proposal, right? So eviction manager could be when they exhausted both memory and the swap, and we might kill the guarantee drop first. That's might be the problem, reverse priority problem. We need to consider that. In general, I think this is the right direction we are moving toward. Yeah. But I need to think about how we are going to thinking about how fast we can access the resource, the performance, all those kind of things together. And this is a little bit new dimension we need to consider when we thinking about the quality of the services. Right? So there are ongoing effort to refine of the quality of the services. But there's the potential people might be gaming the system if we don't change. Just take the main idea and gaming this overall system. You try to avoid of the reduce the eviction, and they are using the burstable, and then end about the swap. I just want to mention this is the potential problem, right?
Something that I actually think about this implementation specifically, which I might contest in a moment, but actually the way it currently is, I think burstable pods would be punished more frequently because their effective limit is swap plus memory, but from Kubel's perspective, it's just memory. So the kernel will allow the burstable pods to go above the limit as the kubelet understands it. Like the kernel will allow it to happen, but then the kubelet will see. So actually burstable pods will be killed first, which does line up with the QoS expectation, though it maybe should be best effort really first. The thing though that I wanted to mention is actually I don't think that is, I think it may make, in contrast with that unexpected boon, I actually think it would be maybe better if the limit in total was swap plus memory. Like the kubelet was considering swap plus memory for burstable pods as the effective memory limit and comparing that usage, because it's a little bit weird to me that the container basically at steady state, not really at all being threatened to be killed by the kernel, would get evicted so early because it is like able to use more memory than the kubelet is really thinking about when considering the limit. So that's, I don't know if that is the right way, but the way it currently is actually done would mitigate that specific issue.
Yeah, that's interesting. I need to think about it for a second. But yeah, thank you for those thoughts.
I do agree, though. I like the direction that this is going, and this is kind of similar to what I was talking about a couple months ago, where we basically use swap plus memory as the amount to decide about eviction because they're so intertwined. So I like where this is going. Evan?
I was just curious. I mean, I think the biggest question we had around like swap evictions was understanding if an eviction is happening due to memory or swap plus memory. Do we have any like UX and logs or anything on like the pod eviction message that could actually tell it that like we're having a swap aware eviction?
So I think that it's pretty easy to add, log entries or something like that. I do. I mean, my next point is, increased debuggability. But yeah, I mean, is log entries what you're referring to, or do you expect something?
I think the biggest concern around swap from pretty much everyone I talk to is support and knowing like what's actually happening. Like if we have a support ticket, can we know that, pods are being evicted due to swap or memory, and kind of thinking through that? Because I think that's what a lot of people's concern around bringing swap GA has been.
Yeah, so I mean, maybe we can hold that thought to the next slide because I'm going to talk about something similar, and then
Yeah, and
maybe
I
it's
mean,
connected.
I've seen your slides. I think there are two parts. Like one, there is obviously swap from a UX, like just Node has swap enabled, but also like pods being evicted in the logs. Like I saw the debuggability like CLI command, but like if I'm thinking from my perspective, I might get like an SOS report of kubelet logs after the fact, and seeing like what evictions are actually happening is helpful just to actually understand, like, because I won't probably have access to like most people's clusters to actually see like why things are being evicted now that we're adding memory plus swap. And even if it is transparent to the user, I think an admin may want to know like what is happening with evictions. Anyway, we can continue on your slides if you want.
Yeah, but for sure. I mean, adding the suffice log entries to understand what's going on is very important. I agree. And if there are any other ways of being more visible about it, then I'd be happy to know about it. And Sergey, yeah, you raised your hand.
In interest of time, I loaded it. Thank
Okay. Cool. So I'll be quick about the second thing. So basically, yeah, as Kevin said already, this is another big concern to understand what's going on and which swap, how much swap can be used and is used by nodes and pods and whatever. There were two past failed attempts to address this. One of them is to add swap as another resource name, just like as memory and CPU and all of those. And it was basically rejected because it was confusing since you cannot explicitly ask for swap as opposed to the other resources. And there was another attempt to add a swap condition to nodes, which also was rejected. Basically, what I'm suggesting is to add the show swap flag to kubectl top subcommands. Basically, behind the scenes, it would just take currently existing statistics, which are not implemented in this PR, but are just out there. And this is basically how it looks like. So yeah, I think, I mean, I assume most of us will agree it's nice to have, but my question basically, if it is enough for swap GA, or is, I mean, is it something else being expected? Yeah, Francesco?
No, actually, regarding the previous attempt. So regarding the kubectl top, yes, I think this specific feature is nice, but I feel it's not enough. And the question is actually about the first two attempts. So they were rejected, fine. Maybe we can, maybe you brought already the conversation to SIG, like, okay, not okay, no. So which direction would you suggest? Get their input. I mean, did you do that already?
I mean, what I feel that we're a bit in a circular, feedback, because basically in the second PR, a lot of people said like, why use a condition? We can use a field, but it's hard to use a field if it's not another resource name. I mean, so making another dedicated field for swap or something like that is so. I mean, I don't. I kind of ran out of ideas, and I feel that everything is not good enough, to be honest. Maybe, yeah, I don't know.
I'm still pro the second one. I still think about the people reject that one. Their reason is not convincing. So I'm still thinking about the second one. It is reasonable one. I'm not sure other people.
Is that reporting that it is a condition that it is swapping, or you're trying to report how much swap is consumed, which are two different things, right? If we just say there is swap, I don't know if it's enabled or there is swap, and enabled includes there's actually some, swap file. Then, I mean, it makes sense to me personally. I agree, Don. What about pods? How do we detect if a pod is consuming, it has swap enabled? Do we need a condition on a pod as well? Or is it just the spec we can look at? I haven't looked at this at all, so.
BPA added the resources in the status of pods. Okay, these could potentially introduce a dependency between the two features, but still, in theory, could we use that field in the status, the resource actually used in the pod status to make, okay, this pod is also using swap. Would that be something worth exploring?
So John, I want to answer. So on the answer, actually, initially, I think the node condition is the first state to we say, okay, this node have the swap and some workload consume. So we didn't propose more because we do talk about like in the long run have the pod level of the details, but because node condition, like node level already rejected, which it is, so we did expand it to the pod. But that's the good comment. We should. But I also, John, do have better comment. It is because it used to be we are insist about the swap condition to node instead like the how much of the even you enable swap and how much consumed. Maybe that's more informative, and we can try. I still feel like the second one is the better, and if we need it, we should fight forward, unless people give suggestion of the better alternative way, right? So
Yeah, I don't think we should let people just be like, no, and
yeah,
not offer a better alternative. You can push back a little harder on that. I haven't looked at that one, but I'm getting kicked out. But yeah, that makes sense to me.
I think what SIG architecture can do. No, there's no swap from completed from the Kubernetes cluster. I'm go for it because this feature add tons of the complexity to other features on the node, right? But in reality, there's many customers already using this one, so they couldn't say no. Then, if they don't want to have the user or admin knows what's going on in the node, can they propose other alternatives? Okay, I'm not buying that. No, okay. I just don't have time to fight through that one because I know we couldn't meet that deadline. So that's why I said, okay, there's more urgent things for me to do. If we need it, I'm still keen on the second one. I'm still thinking about that's the first step to raise some awareness to the node, have enable of the swap, and then we can move forward. Yeah, I buy some other suggestion, but I don't buy simple no because we have to support the swap.
Yeah, I just wonder what's the right platform to, convert this conversation. If it's right here in the PR, opening an issue about it, or yeah.
Yeah. Okay. Thanks, Francisco, to suggestion to ask them alternative way. Yes, we should.
Thank you.
Bye.
I think we're out of time. Itamar, few suggestions. Generally, those kind of things are, I mean, resolving circle dependencies on Kaplan, going around, typically, easiest way to resolve, like, not easiest, like, best way to resolve it is to go and maybe have some dedicated work stream for that and start writing down some decisions. And once we get those decisions right down, and like, I mean, easiest one right now is, I think we're still walking around with the fact that this is a suggestion without any API change on a pod spec. So we don't introduce memory swap on pod spec, and we believe that it's workable for many scenarios. So I think many people still have reservations about it, and that's why every other decision after that is kind of locked on like what will be the next adjustments to API, like how those decisions will look like when we will change API. And since we don't know how we change APIs, it's hard. So if we can lock at least like this is our future for next 5 years, we don't introduce swap on pod spec, then it's easier to converse further and like make further decisions.
Thank you. Yeah, I'll indeed try to resolve the secular dependence.
Great. Thanks, everyone. We'll continue this in the future. All right.
Thanks a lot. Bye-bye.